Hey, good morning, everyone. Welcome to our midweek here. Let's see if I guess midweek was yesterday. It doesn't matter though. So here we go. We're kicking over into the next part here of our linear function topic, talking about slope-intercept form. And I've hinted at this form a few different times over in the past relations and functions unit. And we're actually going to talk about what this form looks like and pick it apart to figure out what kind of information it can give us, because it's quite useful. And you've actually already seen and might have talked about this form back in grade 9. So if anything, this might be a review for people, and some it's going to be some brand new stuff. So let's dig on in. I'm hoping to make this fairly quick, not 20 minutes. So let's look at what slope-intercept form is. So the form itself, right? Well, let's figure out what the form looks like. So at its essence, it looks like this: y equals m times x plus b. You've seen this and heard this millions and millions of times, I'm sure, by the time you've hit the end of grade 9. So I'm here to bring it to you for the millionth in one time. You're welcome. Okay, let's pick this apart and figure out what slope-intercept form actually gives us. So slope-intercept form is basic. It's just a basic way to pretty much give a form for a linear equation. So we can say this is just a general form for a linear function. We'll say function, not equation. I'm just going to kick this down so we're not getting too squished. And what does each part in this form represent? What does each part represent? Well, let's label what we can here. Y, this is the y coordinate of a point on that line, of point on function. And I'm going to say on the function is going to become very important later on. Let's do the x then. Well, this is just the x coordinate of a point on function. And it could be any coordinate as long as it's on that function. Well, what about m? What about m? You might remember that this represents this is our slope. This is what we were talking about the lecture before, slope. Or we can say we remember slope is also the same as the rate of change. We can let's also say that this is the dependent variable, right? And over here was our independent variable. And then for b, well, b is, it's going to be a kind of a new one. It's called our y-intercept, or the point where x equals 0. So right in our equation itself, it's kind of nice because we get a lot of information about our function. If we can write a function in this form, it tells us a lot about our relation and our function, right? Because we can get the slope right out of this. We can just figure out, well, whatever number is in front of x, that's going to be the slope or the rate of change. And we can also get the y-intercept rate of it. So we don't have to do our silly thing of plugging in 0 for x and then solving our equation, because we can just look at, hey, what's at the end of this equation? That number is going to be the y-intercept no matter what. So let's look at some examples with this. Let's look at some examples. And let's do the examples down here. So we got example 1. And let's say that we want to determine the slope and y-intercept of each of the following. Determine slope and y-intercept of each of the functions. ... Okay, let's look at A. Let's say that A was asking us y equals negative 4x plus 7. Okay, and let's say that this was a distance in kilometers versus time hours for a function. I'm just giving some context. Most of these questions don't actually have context, so it's a bit hard to understand. So what would be the slope of this? Well, the slope, remember, this is our m term, and that equals our slope. So therefore, slope is equal to, we could say this is equal to negative 4. And then just to give this context, if this was measured in kilometers per hour, or we were comparing distance versus time, this would be 4 kilometers per hour. If there was no context given to you, you would just write negative 4. This is why I do that, because -4, just saying slope is -4, that doesn't give you much information. This is telling you that for this function specifically, that models distance versus time, if it was modeling distance versus time, the driver is going, we could say he's going in reverse, right? Because it's a negative. He's going in reverse at 4 kilometers an hour. Oops, I was going to make sure my mic is recording. Good. Well, what about our y-intercept? Y-intercept equals 7. And remember, if we're measuring distance, versus time, distance would be on our y-axis, right? Because that is the dependent variable. So this would be, our y-intercept would actually be 7 kilometers. So remember, this is our b, y-intercept. And then we could make up a story about that. Let's say that he started traveling 7 kilometers from home, or maybe he was 7 kilometers away from his driveway, and then he reversed back into his driveway, because that would give story to the negative here, because he was driving backwards, right? So, or he was driving in reverse. It's kind of like whatever you want to do for these stories, right? It just helps give context. Okay, let's look at a bit more of a trickier one. Let's look at this one. So let's say we add something like 3x minus 4y minus 12 equals 0. So obviously this is not in slope-intercept form, right? Because everything is on this side. Everything's on this side, right? We have an x term, we have a y term, we have a constant term. We got 3 terms in total, and we want to get it in the form of y equals mx plus b. So let's think of a way that we can change this up to make this a bit easier. Well, we know that we need y on one side. We know that we need this term on its own. So how about I just take this term and move it to the other side. So 1, take y term and get it on its own. And I'm just choosing to do just this one, move to this side, because that's just one move, right? You could easily just take this and move it to this side, and then y would still be on its own. But if we do this, it just makes our lives a little bit easier, right? So I'm going to do that. And what do we get? Well, we get 3x minus 12 equals, and if I move it to that side, what did I do? Well, I added 4y to both sides, right? So we get positive 4y on this side. Now, what I'm going to do here, I'm going to flip this essentially. Ooh, I did not want to do that, because I want to read this from left to right starting with my y. And I mentioned this before, but you can interchangeably just switch the sides here. It doesn't matter about like putting -4y over here and then -3x plus 12. I'm just going to rewrite this out so that I can read it from left to right with my y first instead of right to left with my y second, right? So this is the same thing. We can just do this. 4y equals 3x minus 12. Okay, this is the exact same thing. We're not changing anything. Sometimes people have a hard time understanding this. It's the same thing as saying 32 equals 8 times 4. But instead of writing it that way, we're writing it as 8 times 4 equals 32, right? We haven't changed anything, and we don't need to move anything special. We're just writing it in a different way, different perspective. So I'm going to carry on with this form here. So we have 4y equals 3x minus 12. And we're not done yet, but we're close, right? We need to get this y on its own. Right now it's being divided by 4, multiplied by 4, so we need to divide by 4. And that means that we have to divide everything over here by 4 too. Okay? And this is the way I prefer you write it, because you could do the whole thing over 4, but then sometimes people get lazy and they just leave it like that. If you just write every term on the right-hand side divided by 4, you take into account everything. So let's round this away then. And what do we get? Well, we get y equals 3 over 4 we can't really do anything with. So this just becomes 3 over 4 times x. And I also prefer writing it like this, because this way you see the slope as its own thing, right? Instead of 3x over 4, it's the same thing as writing 3 over 4 times x. And this way you see that this is your m value. This is your slope, right? So do that whenever you see a fraction, because it just makes things easier, I think, to see. And 12 divided by 4, or negative 12 divided by 4 is 3, right? So now we're in our form. We're happy. So we have that. So our y equals 3 over 4 x minus 3. This is our m. This is our b. So therefore, slope, I'm not going to give this one any context, just for something different, is positive 3 over 4. And y-intercept is negative 3. Never forget that negative. If there's a negative there, it has to come along. Negative 3. Okay, so there's actually the first 2 points done. What is this form? Converting to slope-intercept form. Bada boom, bada bing. So how do we go about checking a point on a line? How do we go about checking a point on a line? Or actually, sorry, let's slow down. Let's do something really quick here. Let's do something very quick. I'll give in one more question here with this. The paper, black. Okay, let's do example 2. And let's figure out, let's say that the example 2 is asking, oops, write the equation of the function below. So let's say we had a function. Let's say we had a function that looks something like this. And I will write my function, and let's say that it goes let's do something a bit different, you know? Let's try that. Okay. This is our function. And we need to figure out what the equation of this line is. We need to figure out what the equation of the line is. So, actually, I'm just going to erase those arrows. Sorry, I'm just going to extend it longer. Come on. Just a bit longer. Okay. So what's the equation of this line? So let's go back to figure this out nice and quickly. Let's recall y equals mx plus b, because we can use this form to define this function. We can use this form to define this function here. So how can we do this? Well, we need two parts. We just need two parts, right? We just need the slope. We need the slope. And we need the y-intercept. Let's get the low-hanging fruit. We can figure out the y-intercept just looking at this graph, right? Because the y-intercept occurs right when this line crosses the y-axis here. Crosses the y-axis. Let's label our axes too, because I usually do that. So what's the y-intercept for this one? Let's look. Hey, y-intercept occurs right here. Okay. Y-intercept's right there. And so what point is that? Well, this is point 0, right? Because it's on our x-axis. And let's count up how many points. 1, 2, 3, 4. 0, positive 4. There we go. We have half of our work already done for our equation. So we could say that b equals 4. Okay, positive 4. We're done there. So now we just need the slope. The slope's usually the trickiest one because we need to use our special equation to figure this out. So what we need to do is find 2 nice points on this line that we can use in our slope formula. And what I'm going to do, let's say that I'm going to use this one right here. And then what you might not be able to know, or what you might, wow. What you might be wondering is, well, can I just use this point too? Can you just use this point here as well? And the answer is, yeah, you can. It's completely fine to use that as a point. And we could show you that. So we can use this also as a point. So let's say that we also, I was thinking a little bit too hard about that. We can use that as well. 0, 4. And let's label these. Let's label these as my x1 and x2 right off the bat. So this is our x1. This is our y1. I did not label this. Idiot. This was our, what point was this? That's why I didn't figure it out. So this is going all the way to here. So 1, 2, 3, 4, 5, 6, 7. So this was 0.7. And what was our y value? Well, this was 4, 5, 6, 7, 8, 9, 10. 7, 10, right? Come on, go way out. Look. Let's label those again. So this was since this is our second point, x2, y2. Okay. So let's figure out our slope. So remember, slope equals y2 minus y1 over x2 minus x1. Well, y2, what was our y2 value? Our y2 value was 10. Minus, what's our y1? 4. Our x2 was 7. Our x1 was 0. So we're left with, what's 10 minus 4? Well, that's just 6 over 7. There's our slope. Equals m. Okay. Should put m with an exclamation mark because that means something else in math. So our equation, therefore, is y equals, what was our slope? Positive 6 over 7 times x. And then what was our y-intercept? What did we say our y-intercept was? 4 plus 4. That's it. Simple as that, folks. So just have 2 more things here, and we're good to go. So what do we need to do? Checking if a point is on a line. So let's say, example 3, suppose we have a function of y equals negative 5 over 4 times x minus 6. And let's say that we want to check to see if point 12, negative 21 is on the line of our function. So normally to solve this, you might think, well, hey, I can just graph this and I can check on the line to see if 12 and negative 21 lies directly on that linear function. Problem is that takes a while, and it takes a long time depending how fast and how slow your function grows, right? Because you could be looking for a number in the hundreds, thousands, millions. So there's got to be an easier way to check it. And the way that we're going to check it is we're going to do it's essentially a left-hand side equals right-hand side check. So this part I'm going to call just left-hand side. This part over here I'm going to call right-hand side. And we're going to see if left-hand side equals right-hand side, because if in our function, so over here was y equals mx plus b, and sorry, I'm going to go right back to the top here. Remember our y was our y coordinate of something and our x was the x coordinate of a point. If we plug in everything and our y coordinate ends up equaling everything on our right-hand side here after we simplify and solve, then the point is indeed on the line. But if it does not equal, if this does not turn out to be true, then the point is not on the line. So we can generalize this with a rule. If left-hand side does equal right-hand side, the point is on the line. And then if left-hand side does not equal right-hand side, the point is not on the line. Okay. So let's see this in practice. So what did we have up here for our equation? We had y equals negative 5 over 6 x. Oh, sorry, 5 over 4 x minus 6. 5 over 4 minus 6. And we're checking the point 12, negative 21, right? So we're going to plug in. So this is our x value. This is our y. We're going to plug in. I'll do this in a different color. Let's do a nicer color. We're going to plug in x to here, and we're going to plug in y over here. So plug in values, right? And so let's see what we get if we do that. So when I do this, I'm going to do my brackets. I'm going to open up some brackets. Negative 21 equals negative 5 over 4, bracket 12, because that's our value of x, minus 6. And we're going to solve. This side's already solved, right? It's already on its own. So we just need to figure out what the heck this is over here. And if this equals negative 21, then the point is on the line. If it doesn't, if it's anything even less, even like a decimal less, we're out, right? So over here, we can just remove those brackets because it's just negative 21 on its own. Let's figure out what's going on here. So we have a 4 up here, down here, and a 12 up here. We can cross multiply these, right? The 4 goes into itself how many times? 1 time. How many times does it go into 12? 3 times. So we're actually just left with negative 5 times 3. So negative 5 times 3 is what? Negative 15 minus 6. And you'll see, well, hey, negative 21 is equal to negative 21. True statement. So therefore, since left-hand side, this is good to leave these comments too. Left-hand side equals right-hand side. point 12, negative 21 is on the line. That's it. Yeah. So we got one more. I promise. And we're just looking at something like this. What are we on now? Example 4. Example 4. So let's say that it was asking us, consider the equation y equals negative 3x plus b. Suppose the point negative 4, negative 3 is on the line. Suppose it's on the line. Determine b. Determine what the value of b is. Determine the value of b. So once it's determined the y-intercept. So we know what a point on the line, and we know what the general equation is. Okay, so let's figure this out. Well, so we have y equals negative 3x plus b, and our point is negative 4, negative 3. Essentially, all we're going to do is take those, and we're going to plug in each component here. This is our x, this is our y. So we're just going to plug in and solve for b. So we do this, let's see what we get. So we have negative 3 over here for b, right? Equals negative 3 times negative 4 plus b. So you see how we went from something that had 3 unknowns to now something that only has 1 unknown. So this is solvable, right? So let's take this as just negative 3 equals, what's negative 3 times negative 4? It's positive 12 plus b. Okay, we need to get b on its own. What's the easiest thing to move? Well, right now 12 is being added to b. 12 is being added to b, so let's remove 12. Let's remove 12. Minus 12. Minus 12, we got to do it on both sides. So over here we have negative 3 minus 12 equals b. What's negative 3 minus 12? Negative 15 equals b. Therefore, the full equation is y equals negative 3x minus 15. And that's it. So on the assignment, I will ask you a question exactly like that, and one that's also very similar, except you're going to be given b, but you're going to be told to find what the value of m is for the question. So you'll have to use the same principles here, just plug in and then solve for m. So that's it for today. I hope that was super helpful. I hope you're all having a great week. We will reconnect tomorrow with the quiz, but you will not hear from me until next week. So have a wonderful weekend, everyone. Hope you're staying safe. Hope you're staying healthy. Take care. Bye.